Actually, according to your books, we usually follow this kind of notation. We take temperature here and we give heat along x-axis. Now, right now I have ice of particular mass, let's say 1 kg, 15 grams, anything. I have mentioned the temperature. The temperature here is minus, let's say, 50 degrees Celsius. Okay. Now, to convert this ice, so right now what I'm doing, I have a ice pack which is at minus 20 degrees Celsius. I have to convert it into water first, and then I have to convert it into vapors. Okay. So what I'll be doing, first of all, I'll be increasing the temperature of ice from minus 20 to 0 degrees Celsius, so that it will be in a state so that it can change its state, right? So in that case, I'll be using this formula, which is mc delta T. Mass we have, specific heat capacity of ice we have, and change in temperature we have. That is from minus 50 to, okay, I've taken minus 20 here, so I'll write minus 50. So minus 50 to 0 degrees Celsius. So in that case, temperature will keep on increasing, and so would be the amount of heat given to the body. Now, up to this thing, the formula used here is mc delta T, where C is the specific heat capacity of ice. Okay. Now, once all the ice has been brought to the condition that the temperature is 0 degrees Celsius, now the further heat, the further heat given will change the state of ice. Okay. So in that case, amount of heat given to the ice pack is now absorbed by the ice, and it's used in, or it's utilized in changing its state from ice to water. In that way, temperature will remain constant till the point when whole of the ice has been converted into water. So what exactly is happening? Heat is being absorbed, that means the value of heat is going to increase, but temperature will remain constant. So what will we get? From ice, we'll get water at 0 degrees Celsius, right? So here, temperature remains constant. We had ice at 0 degrees Celsius here, and now I'll get water at 0 degrees Celsius here. Now, once the total ice is converted into water, any further heat given to that water will increase the temperature of water. So now the graph will again change, because temperature is increasing, and it will go till here, the value was 0 degrees Celsius, and it will go up till what? Up till 100 degrees Celsius, right? This time the formula used will be again mc delta T, where C is the specific heat capacity of water this time. Now, what was the formula used in this part where there was no change in temperature? It was ml. This ml is latent heat of melting this time. Okay. Now, after mc delta T, now we have brought this water which was at 0 degrees Celsius to water which is at 100 degrees Celsius. We have increased the temperature. On further, when complete water has attained a temperature of 100 degrees Celsius, water is going to change its state and it will start vaporizing. In that case, it is going to form water vapor. So now, any further heat absorbed by this quantity of mass is going to get converted into changing state of this body. So now, temperature will still remain constant until whole mass is again converted into vapors. So now, heat is again absorbed from this point to this much point, but there is no change in temperature. So formula here would be again ml, but this time L is latent heat of what? Vaporization, right? There are two things, latent heat of fusion and latent heat of vaporization. This latent heat of melting or latent heat of fusion, right? And now once complete water, the complete mass of the water has been converted into vapors, any further heat which is being given to that mass will increase the temperature of steam or vapors. So now temperature will again start rising and we can take it to any temperature. So this is how graph takes the place. So the formulas used are increasing the temperature of ice mc theta, changing the state of ice ml, increasing the temperature of water mc theta, and again changing the state of water ml. So this is how we study all the things related to change of state.